Hi, this is an explanation of the textbook problem on page 27, problem number 2. We're using a computer simulation to look at a battery, resistor, and light bulb circuit. This is a switch, and this is an ammeter that measures the number of amps that we have going here. This battery right here is set to 10 volts, so I'm going to put that in my chart over here where I'm going to keep track of my numbers. So there's 10 volts, and the resistance is set at 10 ohms. This little symbol right here is the Greek letter omega, and it's pronounced ohms after a guy named Ohm who studied this sort of thing. Also notice on the resistor it's got these 4 stripes. Electrical engineers and electricians can recognize the different kinds of resistors by the pattern of the color stripes, and that's related to how much resistance is in there. So if I make this a 12 ohm resistor, it changes the stripes. I'm going to bring that back down to 10. And this light bulb can handle a maximum of 4 amps. So if I go above 4 amps on the ammeter here, by changing the other settings, the light bulb will break. So let's turn on the circuit. I'm going to put in the resistance that I have over here in the chart. I'm going to turn on the circuit, and you can see the little red electrons flowing through the circuit from the positive to the negative terminals of the battery through the resistor and into the light bulb. And you can see that the light bulb lit up just a little bit. And now I've got 1 amp. That's the current that I've got, so I'll put that in the chart. And without more data, there's not a lot I can tell about this so far. So let's see what happens when I raise the voltage. Let's see what happens to the current. I'm going to keep the resistance at 10 and raise the voltage. So let's raise the voltage up to, say, 20. You see the rating on the amp meter going up? So now I've got a voltage of 20. I'll put that in here. I kept the resistance at 10. And what happened to the current? It went up to 2 amps. So there I can kind of see a relationship. As voltage increases, current increases, while I keep the resistance the same. Let me say that again. As voltage increases, current increases. So voltage and current must be related by what kind of variation? Think about it for a minute. Also, what happened when I raised the voltage? The light bulb got brighter. Did you see it get brighter? Let's raise the voltage even more. How about up to 30? And we're going to keep the resistance constant at 10. Watch the light bulb this time as I raise the voltage. Remember that this light bulb can handle a maximum of 4 amps. So let me raise the voltage up a little bit. Do you see the light bulb getting brighter and the amps on the ammeter going up? Let me find 30 volts right there. And the light bulb is a lot brighter now, and the ammeter gives us 3.0 amps. So as we've kept the resistance constant, hopefully you can see that the voltage, as the voltage increases, the current also increases. Let's see if we can hold the voltage constant now and increase the resistance, and then we'll see what happens to the current. So as I increase the resistance, we'll keep the voltage at 30, and as I increase the resistance on this resistor up to, say, 15, hard to get it right at 15, but there we go. Now we've got a 15 ohm resistor here. And what happened to the current? The current went back down to 2.0 amps. So, keeping voltage constant, as resistance increased, current decreased. So what kind of variance is that? Think about it. We'll keep the voltage at 30, and we'll take the resistance up another notch to 20. I think. There we go. And as the resistance went up to 20, now the current is down to 1.5. Notice that this was not a linear relationship. As the resistance changed from 10 to 15 to 20, the current went down by 1 and then down by 0.5, which is not linear. But as resistance increased from 10 to 15 to 20, current decreased from 3 to 2 to 1.5. So that's what kind of variation. Of course, with the light bulb here, what we want to do is make it as bright as possible. So looking at some of our settings, the current was highest when I had the voltage at 30 and the resistance at 10. So let me go back to those values. Oops. What happened? Did you see it? I changed the resistance. I had the resistance going down to, got as low as 7.6. The voltage stayed at 30. So as resistance decreased, what happened to the current? As resistance went down, current went, well, look at it over here at 3.94. But we have an awfully bright light bulb. So as I bring the resistance down a notch to 7. Right there at 7.5. When the resistance is 7.5, the ammeter reads exactly 4.0 amps, which is the maximum rating for this light bulb. So if I want to use a 7.5 ohm resistor, the maximum voltage that I can have is 30 volts. If I put in a slightly bigger battery, because anywhere above 30 volts, I have more than 4 amps. The light bulb can only hold 4 amps, and broken light bulb. So there's a relationship there between voltage. As voltage increases and current stays the same, and resistance stays the same, what happens to the current? Do they go in the same direction or different directions? In that case, is it direct variation or inverse variation? And the other side of the street, when we keep voltage the same, as the resistance increases, current decreases, but then when I brought the resistance down, current went up in different directions. So is that inverse variation or is it direct variation? And how would you represent that in an equation? So you are going to have a chance to play with this now too. Did I stop recording? Nope, still recording. You're going to have a chance to play with this too on your iPad. There's an app that you've been emailed a link to that shows the same kind of relationships, where as the voltage increases, other things change, and as the resistance changes, other things change. And you're going to get a chance to play with that and figure out some of the relationships there. You are going to record your findings in a worksheet that looks like this. You're going to follow along with problem number 2 here. And as you change the settings according to the directions in the textbook on page 27, problem number 2, you can record your findings in a table like this, like I did, and describe what happened. Then we're going to explore a little bit about what the formulas actually look like. So good luck. Have fun playing with the iPad app, and we'll see what happens.